Hello, dear students. This is your Jagan sir. This is your Jagan sir, and welcome back to our YouTube channel Physics with Jagan sir. And we have successfully completed three classes. And in these three classes, we have seen Newton's first law, Newton's second law, Newton's third law, and momentum application of the momentum. And after that, yesterday we have seen some numericals. And again, here we are going to see some more numericals based on the normal reaction or normal force. These problems are based on normal force. See, the first one is two blocks M1 and M2, M1 and M2. Force F is acting on M1 placed side by side on a smooth horizontal surface as shown in the figure. A horizontal force F is applied on the block. Find the acceleration of each block. Question A. Find acceleration of each block. And here you can easily analyze that only one force is acting on the system, and because of that force, m1 m2 are moving simultaneously in the forward direction, so both of them should have the same amount of acceleration. So we can find here that acceleration by using set of all the forces acting is equals to total mass into acceleration. This is what is Newton's second law of motion for translatory motion, right, or straight line motion. Set of all the forces is only one force F is acting here, and mass is equals to m1 plus m2 into acceleration A. That acceleration A is equals to, we can say, F by m1 plus m2. F by m1 plus m2, right? Now second point is, see here, the B part of the question is find the normal reaction between the two blocks. Find normal reaction between the blocks. Find the normal reaction between the blocks. See here, see here. The first point is we need to draw free body diagram for M1 and M2. M2. And here the normal reaction for every equal action, opposite reaction is existing. So the normal reaction between these two objects remains same in magnitude wise. And here for the object M1, force F is acting. For M2, set of all the forces acting is equals to mass into acceleration. Now, can I write set of all the forces is only normal force is acting, which is equals to M2, and acceleration of the system is equals to, here as we have seen, F by M1 plus M2. So, N is equals to Fm2 by M1 plus M2. And the question is find the normal reaction between the two blocks. Yes, this is the normal reaction between the two blocks. Clear? I hope I am very clear from my side, right? Now let us go for the second question. Again and again I am saying, here I am discussing the conceptual questions and which are little bit typical in understanding, that will make, and this class will makes you to be more comfortable in solving numericals at your level of examination. Clear? Then next one is, here 1 kg block and 2 kg block, and here 6 newtons is acting. This is what is the first diagram. Two blocks of masses 1 kg and 2 kg are placed in contact on a smooth horizontal surface as shown in the figures. A horizontal force 6 newtons is applied on 1 kg block and 2 kg block in two different cases. Find the force of interaction of the blocks. See here, they are asking us to find the force of interaction. The force of interaction represents normal reaction between the blocks. That means for 1 kg block, obviously 6 newtons is acting in this direction, and normal force due to this block is on this side, and normal force due to this block on this block, right, 2 kg, and they are asking us to find what is that normal value. And as we have seen in the previous problem, we first find the acceleration. So finding acceleration here, acceleration finding acceleration, a is equals to f by m1 plus m2, as we have seen in our previous example. That's why I'm writing directly. And f value is here 6, mass value is 1 by 2, which is equals to 2 meter per second square. And 2 kg block is moving in the rightward direction with the acceleration of 2 meter per second square. Right? Now, for block of 2 kg mass, 2 kg mass, right? Set of all the forces acting is equals to mass into acceleration. Set of all the forces is only normal force is acting, and mass of the block is 2 kg and acceleration is 2 meter per second, which is equals to 4 newton. 4 newton. 4 newton. This is the normal reaction between the block 1 and block 2 in case 1. Let us see for the case 2. Case 2, what is the normal reaction between the blocks? And in this case, again, I have to draw 6 Newton, 2 kg, 1 kg. So here, because of 1 kg block, normal force acting on the 2 kg block in the rightward direction. Because of 2 kg block, 1 kg on 1 kg block, normal force N is acting here. And because of this normal force, this block is moving with an acceleration A. That acceleration value is equals to F by m1 plus m2, and f value is 6, m1 plus m2 is, and ultimately it is equals to 2 meter per second square. Acceleration remains the same, but the normal force the existing between these two blocks is here. For 1 kg block, for 1 kg block, sigma f is equals to ma, and sigma f, set of all the forces acting on 1 kg block is only normal force is acting, n, and mass value is 1 kg, acceleration is 2. So in this case, this is 2 newton. 2 newton. Right? Normal force between 1 kg and 2 kg. In the second case is 2 newton. In the first case is 4 newton. So depends on the direction of force acting on the object, the normal reaction between the surfaces will be changes. This is what I want to prove. This is what I want to make you to be understand. Clear? I hope I am very clear from my side. Then third question is find the force of interaction between the bodies as shown in the figure. Blocks are in contact. So here we are going to see application oriented problem. Initially we have seen concept oriented problem. Now we are going to see application oriented problem with some difficulty level. Now see, they are asking us to find the force of interaction, that means normal reactions between three blocks. That is, I am have to draw free body diagram for three blocks, and here F is acting like this, means this F will have two components, and this will be F cos theta. This is theta, means this will be theta. So this will be F sin theta. And here second block M2, M1, normal, normal, M1, normal, normal. So let us say it is N1, it is N2, N2. And understand one most important point here, given force has having two components. One is cos theta component, other one is sin theta component. And here the sin theta component is not at all helping my object to move horizontally. So we can omit the sin theta component, force sin theta component. So the only component which will makes my objects to move in the horizontal direction is F cos theta. Right? Now, as we have seen, F cos theta is the only force acting on the three blocks in the rightward direction. Now, for complete system finding acceleration, set of all the forces is equals to m mass, total mass into acceleration, and set of all the forces acting here on the horizontal direction for the complete system is only one force, F cos theta, which makes my system to move in the forward direction. So here that will be F cos theta is equals to total mass of the system is m1, m2, m3 into acceleration. Then A is equals to f cos theta by m1 plus m2 plus m3. m2 plus m3. Now here for finding n1 for for block m1, set of all the forces is equals to m1 into a, that is n1 is equals to m1 into acceleration value is f cos theta by m1 plus m2 plus m3. This is the normal reaction existing between the first block and second block. Similarly, for block m2 we are going to find normal reaction between third block and second block. See here, for block M2, F cos theta is acting in the rightward direction. Okay. Set of all the forces is equals to mass into acceleration. That is F cos theta minus normal is N2, right? Right. F cos theta minus N2, and the system is having an acceleration A, is equals to mass of the system is m2 into acceleration. Acceleration is equals to f cos theta by m1 plus m2 plus m3. Clear? Then here, okay. See, first of all, we need to find. Okay. Right. F cos theta is not acting on m2 actually. Sorry. On m2, on M2, N2 is acting in the rightward direction, N1 is acting in the leftward direction. N2 minus N1 is equals to M2, acceleration is F cos theta by M1 plus M2 plus M3. Clear? Right. And N1 value is equals to N2 M1F cos theta by M1 plus M2 plus M3 is equals to M2F cos theta by M1 plus M2 plus M3. Then N2 is equals to M1 plus M2 F cos theta by M1 plus M2 plus M3. This is the normal reaction between first block and second block, right? Right, sorry, this is the normal reaction between second block and third block, and N1 is the normal reaction between first block and second block, right? I hope I am very clear here. And I found two normal reactions between, one is between these two and one is between these two. Right, next one is one more application oriented problem. See here, a toy cart has mass 4 kg, mass of the cart is equals to 4 kg and is kept on a smooth horizontal surface, 4 blocks A, B, C, D, 2 kg, 2 kg, 1 kg, 1 kg. So 2 kg, 2 kg, 1 kg, 1 kg. These are the masses respectively have been placed on the cart. A horizontal force F is equals to 60 newtons. F is equals to 60 newtons is applied to the block A. Find the contact force between the block D and in front vertical wall of the cart. So, see, first of all, let us finding acceleration of the system. Acceleration is equals to force applied by total mass. So mass of the cart plus mass first one, second one, third one, fourth one. This will gives acceleration. That acceleration is equals to 60 by mass of the cart is 4, 2, 2, 1, 1. Then A is equals to 60 by 10, 6 meter per second square. 6 meter per second square. This is what is acceleration of the system. Now, finding normal reaction, normal reaction, finding normal reaction. See here for block D, normal reaction is acting due to the wall, due to this wall, and the whole system is moving in the leftward direction with some acceleration A. Now, next point is right. Similarly, for the car, normal reaction is existing due to the block D, and because of this force, the cart is getting an acceleration A. I hope it is very clear. For cart, sigma F is equals to ma, set of all the forces acting is equals to mass into acceleration, and only normal force is acting, that is due to the block D, is equals to mass of the complete system into acceleration. Find the contact force between the block D and the front vertical wall of the cart. Right. Then N is equals to complete system mass is 10, acceleration is 6. This is equals to 60 newtons. This is equals to 60 newtons. Right. Then next one is apparent weight. Apparent weight. See what is apparent weight here. The first point is, let us assume here a weighing machine is present. Here weighing machine, on the weighing machine, if a candidate is standing, this candidate applies certain amount of normal force on the weighing machine, and for every action equal and opposite reaction, weighing machine will also gives some normal reaction on the person. That normal reaction is the value of weight. The value of weight. The value of weight, the person's weight is representing as the normal reaction between the man and weighing machine. Then here you must remember one case. If it is in the rest position, then his mass is, sorry, if it is at the rest position, if I want to find the weight of the man, here remember, if I draw free body diagram for the man, here normal reaction due to weighing machine, that normal reaction actually acts as the weight of the man, and this is mg, then sigma f y is equals to ma by, and here the candidate is at rest position, so acceleration on y axis is equals to 0, and upward direction I am considering positive, downward direction I am considering negative, mass into 0, then n is equals to mg, suppose his mass is, suppose his mass is 4 kg, his weight becomes n is equals to 40 Newton. 40 Newton. If his mass is 4 kg, the weight of the man is 40 Newton. Similarly, if this is not the case, for every time the platform on which the candidate is standing along with the weighing machine should be at rest position. Yes, obviously it is not the always case. Some cases are like this. We are seeing with an example. And in this case, a man of mass m stands on a weighing machine in an elevator. Calculate the reading of the weighing machine if the lift is accelerating upwards with an acceleration a. That means here weighing machine is present, candidate is present, but the whole system is moving in the upward direction with an acceleration a. And the normal force given by the weighing machine on the man is the weight of the man. But if the accelerator is moving in the upward direction, if the elevator is moving in the upward direction with some amount of acceleration, how the normal force will varies? That is, we need to draw free body diagram for free body diagram for that person, normal due to weighing machine, mg, right? For the man, set of all the forces acting is equals to mass into acceleration, and set of all the forces means n is acting in the upward direction minus mg in the downward direction, and here and whole system is moving with the resultant of acceleration a. Acceleration a. So n is equals to m g plus a. G plus a. When he is moving in the upward direction, the weight of the man will increases. Right? Suppose a is equals to 2 meter per second square. Let us assume. Then n is equals to 4, 10, 2, which is equals to 48 meter per, sorry, 48 Newton. 48 Newton. For the same 4 kg person, when he is at rest position, he was weighted 40 Newton. But if he is moving in the elevator, which is moving in upward direction with an acceleration of 2 meter per second square, his weight increases to 48 Newton. Similarly, accelerating downward with an acceleration a. Suppose the elevator is moving in the downward direction with an acceleration a. This is the normal force. This is the mg, and here the again I am saying the free body diagram I am representing for the man, and the normal force existing between the man and the weighing machine is acting as the reaction or weight of the person. Now here, as the resultant acceleration is in the downward direction, we can consider downward direction as the positive. That means mg minus n is equals to ma, then n is equals to mg minus a. Similarly, if he is moving in the velocity of acceleration of 2 meter per second square in the downward direction, now n value becomes 4 kg into 10 minus 2. That is 4 into 8, 32 Newton. 32 Newton. And see here, if the person is at rest position, his weight is 40 kg. If he is in the elevator which is accelerating in the upward direction, his weight is 48 newtons. And when he is moving in the downward direction with an acceleration of 2 meter per second square, his weight is 32 Newton. That means these 48 Newton and 32 Newtons are not exact values, they are the apparent weights of the candidate when he is in accelerated platform. This is what is today's class. This is what is today's class. I hope you might understand very clearly this application oriented critical and logical problems, right? And for daily practice sheets and weekend examination papers, you can follow our Telegram channel. Have a great day. Take care. Bye bye.